The data link layer is the second layer in the OSI reference model. Unrestricted simplex protocol, I required two parties, that is sender and receiver. What is sliding window? In my sliding window protocol, I can able to send bulk amount of frames. Hello friends, a warm welcome to my new session on the data link layer. I'm your Revati ma'am, faculty from the Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. So dear student, in my last session, I started with how to create Hamming code. So what is Hamming code? It is a error detection and error correction technique, and it is used to correct and detect single bit error. And in my today's class, I'm going to deal with elementary data link protocol. So dear student, before going to start the elementary data link protocol, let me to discuss what is data link protocol and where we are going to find the data link. So dear student, if I consider our OSI reference model and if I take the layer, the second layer is data link layer. So the data link layer is the second layer in the OSI reference model. Then what is the use of data link layer? It provides some protocol. When sender and receiver want to communicate each other, then there must be an agreement between those two parties. And if I consider data link protocol layer, it is responsible for transmitting the data between nodes on same local network. So what is local area network? That is nothing but the LAN. And by using data link layer protocol, we can able to transfer the data between the devices which is present in the local area network segment. See here, if this is my local area network, I think that I have sender and I have receiver. Suppose if these two system or if two party want to communicate in the local area network, then I must have the data link protocol. This protocol is also specifies how to detect the error and how we can able to recover the data from the collision, and it also provides the mechanism to reduce or prevent them. So dear student, when I consider local area network, in that segment I can have many nodes. Okay, and each node is responsible for transmitting the data as well as receiving the data. During the transmission or receiving process, if data or device want to detect or recover from any kind of collision, then we want data link layer. And if I consider data link layer protocol, there are two type of data link protocol. One is elementary protocol and another one is sliding window. And from the examination point of view, the sliding window protocol is very important. And if I consider elementary data link protocol, okay, elementary protocols, then this elementary data link protocol is further classified into three types. One is unrestricted simplex protocol and another one is a simplex stop and wait protocol, and the last one is a simplex protocol for noisy channel. And if I consider a simplex stop and wait protocol, this is for noiseless channel, and this protocol is for noisy channel. So here elementary data link protocol is further divided into how many types? 3 types. Which are the 3? One is unrestricted simplex protocol, and another one is a simplex stop and wait protocol, and the last one is a simplex protocol for noisy channel. Anyway, dear student, let's study all these protocols one by one. At the beginning, I am going to have the unrestricted simplex protocol. In network, if I want to communicate, then I must require 2 node or 2 device. So, one is sender and one is receiver. Okay, so if I consider unrestricted simplex protocol, I required 2 parties, that is sender and receiver. So, then what is simplex protocol? Okay, fine. Before that, let me to consider data communication mode. In data communication mode, we have discussed 3 types of data communication. One is simplex, half duplex and full duplex. So, what is simplex? That is, data is going to transfer only one direction. If I transfer the data in only one direction, then it is called simplex. The best example, one way traveling. If I consider vehicle and all the vehicles are going in only one direction, then it is called simplex. So, one way. So, the data is transmitted in only one direction. See here, if this is my sender, sender can able to send. So, only one direction. Both the network layers are always ready for transmitting and receiving. So here the data link layer is responsible for sending the data as well as receive the data. And if I consider simplex mode, the best example is keyboard. Through the keyboard, we can able to feed the data, but we are not able to receive the data. So, this is all about an unrestricted simplex protocol. Now, I am going to have my second type of protocol under elementary data type, that is data link protocol, that is a simplex stop and wait protocol. So, dear student, please remember this. This is only for noiseless channel. Okay, this protocol is applicable only for noiseless channel. Then what about stop and wait? Stop. Wait for the acknowledgement. Okay, fine. Before that, let me to consider the example here. Think that I have sender A. Okay, fine. Then I have receiver B. Okay, think that sender have 4 packets, that is P1, P2, P3 and P4. Okay, initially what the sender is going to do? Sender is going to send the P1 packet or frame to the receiver. Okay, and waits for the acknowledgement. Okay, fine. When receiver receives the P1, now B is going to send the acknowledgement to A that B want to receive next packet P2. Okay, when sender receives this acknowledgement, then they come to know that now they want to send the packet P2. Now, A is going to send the P2. Okay, fine. And when B receives packet P2 and B is going to understand that, okay, packet P2 is received by B. Now B is going to send the request, that is acknowledgement, to send P3. Okay, fine. When A receives the acknowledgement P3, A is going to understand that B received the packet P2 and waiting for P3. So it is stop and wait. So here all the process is stopped and waited unless they receive the acknowledgement. So it is called stop and wait. So it is noiseless channel. So there is no loss of data packet. So here we have to deal with the problem of the flooding, in which sender sends the data continuously to the receiver and a condition like flood is created at the receiver end. Okay, fine. If I consider data transmission, sender is going to send the data continuously or simultaneously. Okay, they are going to send bulk amount of data. So what is that? Sending bulk amount of data. It's nothing but a flood. Now, is it possible to manage all the bulk amount of data at the same time? No. Okay, to prevent these kind of problems, we are going to have this stop and wait. So, send the packet, stop, then wait for the acknowledgement. So, it is called stop and wait protocol. And this kind of protocol is only applicable for noiseless channel. In the sense what? There is no loss of data packet. But if I consider the third type, that is a simplex protocol for a noisy channel. So what is noisy channel? Noise in the channel. In the sense what? The data bits are corrupted due to noise in the channel. So packet is going to corrupted. Okay, due to the noise. To manage those kind of noise channel, we are going to have simplex protocol for noise channel. So here I am going to have the two kind of acknowledgement. One is positive acknowledgement and another one is negative acknowledgement. Okay, fine. To illustrate this concept, let me to consider two entity A and B. Over. Okay, fine. Now think that A is going to have the packet P1 and P2. Okay, fine. Now according to this protocol, see here, sender A is going to send the packet P1 to B. Okay, when B receives P1, B is going to send the positive acknowledgement that B want to receive next packet. Okay, fine. Now, when A receives this positive acknowledgement, then A is going to understand that P1 is received by the B. Now, B want to receive P2. So, A is going to send the packet P2. In middle, due to some noise in the network, the data packet may corrupted. In the sense what? It is not delivered to B. Okay, now B is going to wait for certain moment or certain timing. Now, B is going to send the negative acknowledgement to A. So, what is the meaning of negative acknowledgement? Here, this indicates that whatever the packet B want to receive, it's not yet received. So, resend that packet. So, that is the meaning of minus that is negative acknowledgement. So according to this protocol, it deals with only noisy channel. The main task is of acknowledgement. Okay, so this protocol is mainly depends on the acknowledgement. So positive acknowledgement indicates that the data packet is received. Then what about negative? Negative acknowledgement indicates that the data packets are lost. So the receiver sends two kind of acknowledgement. One is positive acknowledgement and negative acknowledgement. And if I consider negative acknowledgement, okay, what is the meaning of negative acknowledgement? So data packet is lost, so resend that data packet. Then what about positive acknowledgement? So positive acknowledgement indicates that receiver is received the data packet and waiting for the next packet. Okay, fine. Now I'm going to have my second type is sliding window protocol. I hope all are familiar with sliding window. So what is the meaning of sliding window? I can able to slide the window according to my requirement. So in stop and wait protocol, okay, for each frame I want to send the acknowledgement and I am going to send only one frame at a time. By using stop and wait protocol, user can able to send only one frame or packet at a time. Okay, fine. Now, so this leads serious insufficiency. Okay, because we can able to transfer only one frame or only one packets at a time. So it leads insufficiency. Okay, fine. To overcome this, we are going to have this sliding window. Then what is sliding window? In my sliding window protocol, I can able to send bulk amount of frames. In the sense what? I can able to send more than 2 frames at a time. So in this method, server transmits or sends various frames or packets before receiving any acknowledgement. So in sliding window, sender can able to send various packets at the time. In the sense what? Without receiving any acknowledgement. So before going to receive any acknowledgement, sender can able to send multiple frames at a time. At this point, two-point protocol that assumes that none of the other entity tries to communicate until the current data or frame transfer gets completed. So in sliding window protocol, we are going to assume that we have only two parties. One is sender and one is receiver, and we don't have any other third party, because here we are going to send bulk amount of frames without receiving any acknowledgement. So we are going to send the frames first, then we are going to receive the acknowledgement. So here both the sender and receiver must be agree between their window size. Okay, for example, if sender is going to use the window size 4 or 8, now receiver also want to use same window size, say 4 or 8. So both the sender and receiver agree upon total number of data frames, after which acknowledgement is needed to be transmitted. So here the data link layer requires and uses this method that it simply allows the sender to have more than one unacknowledged packet, so in flight at a time. So here sender can able to send large amount of packet or frames without acknowledgement. Using this method, sender can transmit these several frames before receiving any acknowledgement. Single acknowledgement for multiple frames. So, if sender sends 3 or 4 frames together, then for that frame, I am going to receive only one acknowledgement, a single acknowledgement for multiple frames. So, frame can be acknowledged even when the window is not completely filled. So, for each frame or frame can be acknowledged even though the window is not completely filled. So, in this method, we must have the same size of window at the sender side and at the receiver side. Then what about this window? Window is nothing but the storage. Okay, it's a temporary buffer. So, the window has a specific size in which they are numbered as modulo n. So, dear student, if n is 4, then 2 to the power 4. So, 2 to the power 4 means what? 2 into 2 into 2 into 2. It is 4, 8 and 16. Fine. If 2 to the power 3, it is 8. And how I am going to number? See here. If n is 8, then frames are numbered from 0 to n minus 1. So, what is n? 8. And how I am going to number? That is 0 to n minus 1. So, 0 to 7. The size of the window is represented as n minus 1 and the maximum frame I can have here is n minus 1. Okay, in the sense what? I am going to send n minus 1 number of frames before going to receive any acknowledgement. When the receiver sends the acknowledgement, it includes the number of next frames. For example, think that sender is going to send 3 frames. Okay, and these 3 frames are received by the receiver, and now receiver is going to send the acknowledgement indicating that receiver want to receive next frame. So, what is next frame? That is the 4th frame. Okay, fine. Now, dear student, let me to consider this example. Okay, according to this example, what is my modulo? That is 2 to the power 2, so 4. And what is the range? It is 0 to 3. So, it is n minus 1, 4 minus 1, it is 3. Okay, fine. See here. So, how I am going to number? That is 0, 1, 2 and 3. So, this is at the sender side and this is at the receiver side. Okay, fine. So, this is my sliding window. Oh, this is my sliding window. Now, sender is going to send frame 1 and frame 2. See here, now the size of the window is going to shrink. See, sender sent 1 and 2. So, the size of the window is going to shrink. Now, see here at the receiver side. Receiver is going to receive 0 and 1. Now, receiver is going to send the acknowledgement to the sender that receiver is ready to receive the next frame. Which is the next frame? That is 2 and 3. But what is the size of the window? It is 4. Now, the size of the window is going to increase. So, I have 4 frames Now sender is going to send the frame 2. Okay, sender is going to send the frame 2. And see here, at the receiver side, sender is going to receive the frame 2 and the size of the frame is going to shrink. Okay, here also the size of the frame is going to shrink. After receiving frame 2, the receiver is going to send the acknowledgement to the sender that receiver is ready to accept or receive the next frame. And which is the next frame? That is 3. So, frame 3. See here, it is shrinking. Now, the size of the window is going to increase. So, how many? It is 4 frames, right? Okay, so the size of the frame is going to increase. So, it is shrinking and increase. Over. See here also. See. So, at the sender side as well as at the receiver side, I can able to slide the window according to the user need. Okay, fine. Now, so here both sender and receiver has finite sized buffer. Okay, so sender and receiver must have the finite or fixed size of buffer and it is called windows. Now, the sender and receiver agrees upon the number of frames to be sent based on the buffer size. So, sender and receiver must be agreed between how many frames they are going to send and receive. The sender sends multiple frames in a sequence without waiting any acknowledgement. So, what's the meaning? Sender is going to send multiple frames without waiting any acknowledgement. When its sending window is filled, it's wait for the acknowledgement. So, based on the window size, I can have the frames. On the receiving acknowledgement, it advance the window, so it's going to slide the window and transmit the next frames according to the number of acknowledgements received. And see here, at the beginning of a transmission, so this is at the sender side, the sender window contains n-1 frames. So, if n is nothing but the 4, then how many frames? It is 0 to 3 frames. And when they are sent out, the left boundary move towards inward, shrinking this size. So, shrinking. Suppose if I send 2 frames, okay, then what is the window size now? 2. Why? It is going to shrink the size of the window. For example, if the size of the window is W, so here 4 is nothing but the W. So, the size of the window is 4. If there are 3 frames are sent. So, out of 4, if I send 3, then how many frames are remaining? That is only 1 frame. So, it is W minus 3. So, W is nothing but the 4. 4 minus 3, the answer is 1. Once the acknowledgement has arrived, then the sender window expands to the number. So, once the sender is going to receive the acknowledgement, then the size of the window is going to increase or expand. Okay, fine. If I consider receiver side, at the beginning of the transmission, the receiver window does not contain n number of frames, but it contains n-1 space. So, Here, both sender and receiver must be agreed between their buffer size or window size. Suppose if I have n minus 1 window size at the sender side, then I must have n minus 1 window size at my receiver side. When the new frames arrives, when receiver receives any new frame, the size of the window is going to shrink. Okay, when receiver receives any frame, the size of the window is going to shrink, and the receiver window does not represent the number of frames received. So here we are not going to represent how many frames are received by the receiver, but it represents the number of frames that can be received before ACK sent. So what is ACK? That is acknowledgement. Once the acknowledgement is sent, the size of the receiver window is going to expand or increase. So here the sliding window is going to shrink and expand. Okay, fine. Then what is the advantage here? It performs much better than stop and wait protocol. If I consider stop and wait protocol, sender can able to send only 1 frames at a time. But what about the sliding window? Sender can able to send multiple frames at a time. This method increases the efficiency and we can able to send multiple frames without any acknowledgement. And what is the disadvantage? It increases the complexity at the sender, and receiver might receive data frames or packet out of the sequence. So sender is going to send the frame 1, 2 and 3. But at the receiver side, receiver may receive 3, 2, 1. The sent sequence is different and received sequence is also different. Okay, this leads problem. So these are the disadvantages of sliding window. Anyway, dear student, in my today's class, I started with what is elementary data link protocol. Along with that, I have discussed sliding window protocol. In my next session, I am going to deal with network layer design issue. Along with that, I am going to deal with routing algorithm as well as flooding. Anyway, dear student, let's meet in the next session with the new chapter, that is network link layer protocol. Until that, keep watching and keep learning. Thank you.